So this problem is 6.25 from AOPS Introduction to Number Theory. It says find the largest integer n such that n has exactly 4 positive divisors and n divides 100 factorial. So let's first try and understand this problem mathematically. Like obviously and hopefully we understand every single word here, but we need to piece these words together and figure out the actual meaning. So it says find the largest integer, the maximum integer. We get that, right? Then such that n has exactly 4 positive divisors. Exactly 4 positive divisors. Now this gives us 2 cases for n. And this is actually really key information here. If you depict this wrong, you'll do it wrong. You'll do the whole problem wrong. So one case is that. So firstly, all integers except for 1. So all integers that are larger than 1 have 2 divisors, right? And since n is the largest integer, n is probably larger than 1. So it doesn't seem like that the smallest integer is 1, the largest integer is 1 that divides 100 factorial. And that's exactly 4 positive divisors, right? So we already know that n is larger than 1. So we can figure this out that n has, well, if n is a prime number, then it has 2 divisors. But it has 4 positive divisors, meaning that it's equal to 1 times n and it's also equal to p1 times p2, where p1 and p2 are prime. Because if p1 and p2, if either p1 or p2 isn't prime, then we could give n more factors or more divisors. So it wouldn't have exactly 4 positive divisors. It would have 5, 6, 7, 8, etc. divisors. So p1, p2 have to be prime. So this is the first way to do this, where 1 times n and p1 and p2. And p1 and p2 are, well, not equal. The second case is that n is equal to, well, okay, so n is equal to some random prime number p to the power of 3, so p cubed. Why is this? So the first case is that you have 1 times n, right? So you have this times 1, that's just 1 times n. The second case is you have p to the power of 1 times p to the power of 2. This is how you get your 4 positive divisors. 1, 2, 3, 4. So these are 2 cases. Now it's really easy to forget about one of the cases, which is how I got this problem wrong. So hopefully you don't make the same mistake. Now the next part. So n divides 100 factorial. So what does n divides 100 factorial mean? Does it mean that 100 factorial is a divisor of n, or n is a divisor of 100 factorial? Well, in this case, it means that n is a divisor of 100 factorial. So n is a divisor of 100 factorial. So you can also think about it in this way if you forgot what n divides 100 factorial means. You can think of it as you're trying to find the largest integer. Now, if you're trying to find the largest integer in which 100 factorial is a divisor of n, and n has exactly 4 positive divisors, this number could be infinity, right? Like you could keep going up because there will always be something in the format of these. There will always be some number in the format of either the first format or the second format, no matter how large our number is. So you can't find the largest integer. So it has to be the other way around, meaning that n is a divisor of 100 factorial. So we know the 2 pieces of information over here, and we have to use them. Well, obviously, but like, how do we use them then? So firstly, n has to be well, less than or equal to 100 factorial. So that's great. We have at least like an upper bound. Now we probably want to, so since n is divisor or factor of 100 factorial, we probably want to prime factorize 100 factorial and see what happens. So we prime factorize 100 factorial. 100 factorial is equal to 2 to the power of 50 plus 25. So 2 to the power of 50 plus 25 plus 12 plus 6 plus 3 plus 1. Then and then 3. So we have 3 to the power of blah 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 blah, and then we have 5 to the power of blah 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 blah, etc. Now that doesn't look like the best strategy right now after we tried factorizing it, because you realize that there are too much prime numbers and you'll be writing these prime numbers for a really long time. So what should we do then? Well, we're trying to find, so let's try to figure out the first case scenario then, where there are 2 primes that make up n. So what could these 2 primes be? We want the largest integer, so we just take the best case scenario here. The largest 2 primes, because we want the largest integer of n, and the larger p1 and p2 are, the larger the product is, and the larger n is, the largest p1 and p2 would be, so the largest prime that is less than 100 factorial is, so that is less than 100 is 97. The second largest prime is it's 89. So we need 97 times 89. And let's just do the math here. So some people are probably going to ask, why isn't it any prime up to 100 factorial? Why is it any prime up to 100? Well, that is because if you try to prime factorize 100 factorial, the largest prime you're going to get in your prime factorization has to be a prime less than 100. Okay, so here you have 7 times 9 is 63. 9 times 9 is 81. 81 plus 6 is 87. 7 times 8 is 56. And then 8 times 7 is 72 plus 5, which is 77. And then you add these 2 together, you get 3, and then 7 plus 6 is 13. 8 plus 7 is 15, plus 1 is 16. 7 plus 1 is 8. So you get 8633. That kind of looks like the answer, so bye guys, thanks for watching. But no, that's not the case, because, well, we haven't talked about the second method yet. The second method where n is a perfect cube. So what if that actually produces a way larger number than the first method produces? So this is the answer. Our first method produces 8,633. So let me just box this answer here. That is one possible choice. Or actually, let me circle it. Okay, so what about when n is, well, a perfect cube? Well, the largest or the best case scenario here for p, the only one and only prime number we need is 97. 97 is the largest prime number. That is in the prime factorization of 100 factorial. So we have 97 cubed, which is obviously clearly larger than 97 times 89. So obviously the second method is significantly better. So we do the math, which I guess you can do on your own. But anyways, n is just equal to 97 cubed. So that's just our answer, and you can evaluate that on your own, or maybe using a calculator if you're allowed to do one, if you're allowed to use one in this type of problem. But thanks for watching, bye. So it's important to consider 2 methods and to pick the problem one step by another. Thanks for watching.